Hello.
Hello. Welcome back to my channel. Welcome to my channel and welcome to 24 days of science experiments.
Number 20.
Yeah.
Look at the box. Do you want to tell us what we're doing?
Yes, we're gonna look and experiment with the pH scale. So we're gonna measure the pH levels of different liquids like water, milk, vinegar, and liquid soap. Look at all those pH
Those little strips. All right.
We use something like this. We use this a lot in the restaurant to make sure that the pH of the glass washer is the correct.
Oh, so you've done this stuff before?
I have, but this is way more fun.
Let's bring some of these things over here and bring.
Also, can they see the Christmas forest? Look, we have a Christmas forest today.
That's the theme song of the Christmas forest.
Fair, fair.
All right,
okay,
we've got some different things here. What shall we do first?
Oh my goodness. All right, so to determine the pH, wait, first of all, each measurement requires approximately 10 seconds. So to determine the pH, you compare the color of the strip that we're gonna dip to the pH scale that I have right here.
Oh, you've got your pH scale there? All right,
Yeah.
That's how we're gonna do it.
So you only need one just strip per measurement.
One strip? Okay, I'm gonna pull a strip off.
Pull a strip. Let's start with milk.
Milk, okay.
Okay, pop that in there. It takes 10 seconds and you can watch the strip.
You leave it in or we bring it up?
10 seconds.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
It's not really changed color much.
Not focus on there, but maybe that's the color it's supposed to go.
Yeah, exactly. So I'm saying, let's
let's put it against our pH scale. That's gonna be somewhere in between there, isn't it?
Yeah, it's like between the 6 and a 7, or yeah.
Yeah, that's where I'd put it.
Okay.
So, what do we expect milk to be, according to the book?
According to the book, milk is, I can't find it on the thing, it doesn't say on our one. No, let's try another one. Oh, milk is between 6 and 7. It says it right there. I was looking on this wheel, the wheel
Oh yeah,
of
it does
pH.
say that. Yeah.
Yeah, between 6 and 7. All right.
All right, do you want to do the next one? This
Yes,
is liquid
please.
soap.
Okay, so liquid soap. And we can't use all of these today because we need to save them for another science game.
Now I have diluted this liquid soap just a little bit because it was pretty thick, so I thought I'd just dilute a little. Okay.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh yeah, look how much you can see the difference in this one. So this one, pH scale, is like, again, probably between 6 and 7, but
Probably between 6 and 7, yeah.
further over.
It just kind of looks like wet card though, doesn't it?
It kind of does.
But I think if we try it with this vinegary one,
Yeah, I
the
bet you the
acidic
vinegar
one,
is gonna be
let's see what happens there. So this is the pH scale we've got here. And if we have a look at this little wheel over here, we can see that red is for very acidic and violet is for very basic. So we're expecting this one to turn red or orange.
1, 2.
Oh, that's just
3,
definitely a different color to the other ones.
5, 6, 7, 8, 9, 10. Whoa, yeah, look at that guy.
Oh wow.
Yeah, so like a solid 6, go headed over to a 5.
All right, so we add that over there. Now, Erica, I want to try one more. So we've got
Okay.
milk, which was 6 or 7, which is sort of somewhere in the middle. And then we had the soap, which I can see is actually a little green.
Oh, interesting. Has it? Yeah.
Do you think it's a little green?
I think you're right. I think it's on the 7-ish side.
So closer to perhaps than the 7 on that scale.
Yeah.
So a little greener than the milk. Then we've got a distinctly orange one, which we thought was about a 4 or 5, thereabouts.
What are you thinking?
Give me this one. I just want to try this Lysol
Oh.
and see what happens if we do this one.
All right.
So I don't have a glass because I didn't really want to put it in a glass, so I'm just going to put a little bit in the lid here.
Okay.
A little bit of Lysol there. And then let's tear off another strip. And let's pop it in, see what happens. So
Whoa.
1, 2, 3. I think we don't probably need to wait for 10 seconds.
No.
Let's see where that sits on the scale. What do you think?
That
Oh,
is-
that looks like it's almost exactly an 8.
Yeah. It does.
Definitely up this end.
Definitely up this. I'm sorry, guys.
Scale.
I don't know what's my focusy business is happening
Over
today.
here, yeah, that's around there on the towards the basic side.
Yeah.
So wow, very cool.
Yeah. Look at that. Oh, it's very bright.
Don't
behind
drink
you.
it.
Don't drink that.
It's not good for curing anything.
No, not at all.
Wow.
All right.
Very
what a fun
cool.
day.
So let's have a look at the pH scale.
Yeah.
So the pH specifies the acidity. For liquids, it can be easily determined by measuring strips, which are these ones, changing colour depending on the acidity. The pH scale ranges from 0 to 14. Liquids with a pH from 0 to 6 are acidic. All right, so I felt like it would be the other way around. So a low pH means it's very acidic. Strong acids like citric acid have a pH around 2, while weaker acids around 5 to 6. I like the milk, which is around 5 to 6 or 7. Pure water has a pH of 7 and is neutral. That's interesting. I didn't know that was at all the way the scale worked. So liquids with a pH more than 7 are called lyes, alkaline, or basic liquid bases. They feel like soap water, and soap and other detergents belong to the bases, like our Lysol here, which is, I think, getting darker and darker blue as it goes along.
Oh, yeah.
Yeah.
Put that somewhere safe.
Leave it there. Acids and bases are both corrosive and can be very dangerous depending on their concentration. Acids can affect and destroy various metals, namely the so-called base metals. I don't know which ones they are though. Clothing can be dissolved by acids. Skin contact with acids result in some chemical burns. This is why we keep hearing about acids on our murder podcast.
Murder podcast, yes.
Bases, on the other hand, may damage many substances that are nearly unaffected by acids. In particular, they affect natural substances like hair, skin, or fat.
Interesting.
That's why you use lye.
Yeah, that's why lye dissolves human bodies. Allegedly.
With the exception of aluminium, they don't damage metals. Chemical burns caused by acid or bases have to be immediately and thoroughly rinsed with water. Affected clothing has to be taken off. Thoroughly rinse your eyes if they come into contact with such a liquid and immediately visit a doctor.
A doctor. Oh,
Doctor. So you can see some examples here. Can you see the page there?
Yes.
So right down the top of the pH scale, we've got drain cleaner and bleach, soap, and then down to seawater and water and urine down in the middle. On the acidic side, we've got coffee, tomatoes, orange juice, vinegar, stomach acid, and battery acid right at the top.
Battery acid.
Right at the top with a pH of 0. Wow. pH?
pH.
pH scale.
That's fantastic. What a fun day. I loved it. This is great. We're going to very carefully put these away because we need these for another game in the future or something. And thank you so much for stopping by and joining us today for our science experiment of the day. We only have a few more, so make sure that you like, subscribe, hit that little bell there so that you always get a notification when I post something new, and we'll see you tomorrow.